Welcome to a Solidworks tutorial. In this video, I'll use Solidworks motion analysis to simulate a catapult. Here's an assembly containing the catapult and a long board representing the floor. The catapult is a subassembly, so I'll have to make it flexible to allow the arm to move. Now that the arm will move, notice that the ball is constrained to the cup with two mates. I'll leave those two mates on for now. For easy reference, I've created the assembly with the floor locked to y is equal to 0. This model was inspired by a Science Olympiad project, so I created features in the floor representing the required range of the catapult. Now I'll create two named views. This is done by manipulating the view until you like it, pressing the spacebar, and choosing Named View. Once the view is created, you can quickly snap back to the view by pressing the spacebar. These named views will be useful when controlling the camera viewpoint in the simulation. Once the model is in order, add a new motion study, verify that Solidworks motion is active, and set the motion study type to motion analysis. This catapult is powered by a spring that's attached to these two eye screws. Here are some specs from McMaster-Carr. The spring rate is 2.3 pounds per inch, and the length looks like it might work. I'll create this spring in the motion study. Notice that the most important properties are the spring rate and the unstretched length. The other properties are cosmetic. There appears to be a display bug here, but don't worry, the spring is there. After finishing the spring, click the green apple to add gravity. Check the arrow to make sure it is applied in the correct direction. Now add an angular dimension between the stop board and the throw arm. We'll use this dimension to stop the arm and release the ball during the study. Create a dimension-based sensor and set the sensor to alarm when the arm is near the stop. Back in the motion study, you might want to right-click on the board and change its transparency to make the hidden parts visible. In order to stop the arm, add a new motor set to run at 0 RPM. The sensor can be used to turn the motor on at the right time to stop the arm as it approaches the stop board. Clicking the event-based view icon at the right of the motion study window shows the options for triggering changes during the simulation. Click Add New, set the trigger to the dimension sensor, and set the action to turn the ball mates off. Add another task that will turn the 0 RPM motor on. This should release the ball and stop the arm when the arm approaches the stop. Now toggle back to the timeline view, scroll to find the motor, and right-click on its initial key point. Set the key point to off. This should allow the arm to move until the sensor is activated. Now calculate the study. Something's wrong because the arm passed through the stop. Solidworks only checks the sensor at each frame of the simulation, so we need to increase the frame rate in the motion properties. With a higher frame rate, the study calculation will be slower, but the stop will be more accurate. Recalculate the results to confirm the arm stops and the ball is released. Now insert new viewpoints for the camera. Right-click on Orientation and set it to allow viewpoint creation. Choose the point on the timeline in which you would like to change the view. Right-click and add a key point. Add another key point to the right of the second one. Click on that point and change the view to full ISO. We want the point to be static for the first bit of time, so the first two key points should be set to the close ISO view. The view will smoothly transition from key point 2 to key point 3. That simulation shows the setup is pretty good for the short shot. To study the simulation more closely, let's create some plots and export the data. Use the Results and Plots button to create a plot. Make the sketches visible and track the center point of the ball. Notice that you must give a second reference when plotting displacement. Choose the start line as the reference for the X position of the ball. Oops, I forgot to disable the camera key point creation and I accidentally created a key point. I'll delete that key point and disable the viewpoint creation. This will allow me to investigate different times in the simulation without changing the camera position for the study. I time-lapsed the video, but I added plots for the Y position and Y velocity. Now, if you right-click on the results in the simulation feature tree, you can export the results to Excel. This is handy if you need the numeric results of the simulation. To test the design for longer shots, I'll open the Catapult subassembly and change the dimensions for the eye screw placement. Increasing this dimension will cause the initial stretch of the spring to be bigger. Recalculating the results shows the ball will travel farther before hitting the floor. It looks like with a bit more initial stretch, the spring should get the job done for the long throw too. That's all for now, but if you want to see the ball bounce, check out my next video. In that video, I'll continue with this model and discuss contacts and custom forces. Thanks for watching.